Hi and welcome back to my channel Discover PhD Research Gradually, and I am Bhumika Batra discussing the steps and the alternates to be an expertise in a field. In my previous lecture, I have discussed which statistical techniques needs to be applied when you have just one variable. And when you have one variable, it is termed as univariate variable. Moving further, continuing the previous lecture, I will be discussing about when you have two variables, just termed as bivariate variable. As already explained, bivariate doesn't mean just two variables. It also means when in your objective you need to find the relationship or association and any differences among two variables. In that situation, when there is a term relationship, association, or any differences comes up, then bivariate term is used. So let's check which techniques needs to be used when you have the bivariate variables. Bifurcating this table into two. This is metric, non-metric. Here it is metric and non-metric. These are the dependent variables and these are independent variables. Now let's talk about when your dependent and independent both are metric. Which technique needs to be used here is simple regression or SPSS. When your dependent is metric and independent is non-metric, then you just need to understand which technique to be used in univariate to check your hypothesis testing. So for such thing, you just need to check your hypothesis. Coming back to the second column where your dependent variable is non-metric and independent variable is metric, then you will be using linear discriminant analysis or logistic regression. Coming to the last, when your dependent is non-metric and independent is non-metric, then either cross tabs from descriptives or chi-square test. So when your dependent is metric and independent metric, simple regression and SEM. When dependent is non-metric and independent is also non-metric, then cross-tab chi-square. You just need to check which variable, which dependent or independent is metric and non-metric. Do not get confused and do not mix match any of the column. Every column has its own significance, metric to metric, non-metric to metric, and vice versa. One more thing I need to explain, when there is a hypothesis testing, if you have two categories, for example, you have a two categorical data, gender and marital status, there are two kinds of two categorical data. So when you have two categorical of independent, then t-test will be used. When you have less than 2 categorical of independent, then you will be using ANOVA. This is just for the hypothesis testing. And when we were doing hypothesis testing, when your dependent is metric and independent is non-metric. When your dependent is metric and independent is non-metric. That time I told you in the table we were using hypothesis testing. So for hypothesis testing, what you need to remember is when you have 2 categorical data, you have to use t-test, and if you have less than 2, means if you have 0 or 1, then you will be using ANOVA. 0 means if you have no categorical data, then also you will be using ANOVA. In the same way, if your dependent is non-metric and independent is metric, what I have said, that time we will be using logistic regression and one more, discriminant analysis. This is what I have explained in that table. So here, when you have 2 categorical data of dependent variable, then we'll be using binary linear regression. And we have 2 category or less. Less than 2, which means 0 or 1, then we'll be using multinomial linear regression. Do not get confused with any of the techniques. If you have any question or any problem regarding any of the techniques, you can write in a comment box or can post it on my social Facebook network. If you like this video, please subscribe to my channel and stay tuned for more updates. I will be soon updating the next video on multivariate variables. There I will be explaining the statistical techniques to be used when you have the variables more than 2. Till then, goodbye.